All right, everybody. So this is going to be for question number 18 on the lab. I just wanted to give you all a quick video to help you try to figure it out. So we're going to begin with the question essentially asks you to write an equation to calculate the number of A alleles. The easiest way to do this is to start thinking about how this could work if we were just asked to count the number like originally, without any of the math or the equations or anything. So imagine if I gave you a population here of 6 individuals. 3 of them are capital A, and 3 of them are AB. I asked you to calculate, just tell me, how many A alleles are in the population. I think almost every one of you would pretty easily say, well, I could just literally count them. There'd be 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 A alleles in this population. It's pretty straightforward. But it becomes harder once the population gets a little bit bigger. So if I asked you, maybe there's 35 individuals with AA, and there's 15 individuals with AB. Now calculate the A alleles. And then you'd be like, okay, well, I don't really know how to approach this. So here's how we could do this algebraically. Let's think about what we did instead of counting to actually calculate the number of A alleles. So what we did was, for every individual with AA, you can see that there's 2 A alleles, right? Every individual with AA has 2 A alleles. And so you know that if you have 3 individuals with AA, 3 individuals, all you need to do is multiply that by 2, and then you get 6 A alleles from this population, and we can verify that by saying 1, 2, 3, 4, 5, 6. Great. But for every individual with AB, they're only generating 1 A allele. And so if we were to add those together, we would get 1, 2, 3. And so if I know there's 3 individuals, we don't need to multiply by anything, we just know that's 3. And to find the total, we could just add 6 and 3 together. We know 6 plus 3 equals 9. And so we can find the combination of the alleles just based on multiplying however number of AA we have by 2, and then adding it to just the number of AB. So we can do that here too. If we have 35 individuals that are AA, we can multiply that by 2, because we know that each individual with AA gives us 2 A alleles. So that's actually going to give us 70. And then we just need to add the number of individuals that are AB, 15. And when we add those together, you get a total of 85 A alleles. And so we can figure that out for now basically any number of individuals with AA or AB. The question is, how is that going to help us on this lab? Well, given that we know this information, we can write an equation for it. If we, instead of AA, we just called every individual with AA X, and instead of AB, we called every individual with AB Y, we know that we want to add them together, so we can put a plus. We know that we have to multiply X by 2, so we can say 2X. And we just want to add however number of Y, so we can just add Y. So 2X plus Y will give you the number of A alleles. And so now the question is, well, what are X and Y in our mathematical formula? And so we know that X is actually represented by the number of AA. We've already calculated the number of AA. That should be in K4. And Y is the number of AB. We've already calculated that, and that should be in K5. And so you need to write an equation that essentially multiplies K4 by 2 and adds K5 to it. And that'll give you the number of A alleles. And then you can do the same for the B alleles to help you figure that out.